Today we are going to study numerical methods to solve algebraic and transcendental equations. We are going to study one false position method, or it is also called as regular falsy method. The second one is Newton Raphson method. So here, by numerical methods means, let me explain why we go for numerical methods. See, for example, if I consider a simple equation, so like, see, I consider a simple equation, simple quadratic equation, x squared minus say 5x plus 6 is equal to 0. Right. So if I want to solve this equation, I factorize this as x minus 3 times x minus 2 is equal to 0. Therefore, the solution, the solution is x is equal to 3, x is equal to 2. That means 3 and 2 are the roots of this equation. So such methods are called as direct methods. Direct methods, right? Or analytical methods. Analytical methods. So here we make use of certain rules and certain formulae to arrive at the solutions. See, some simple equations. Say if I consider, say, sine x is equal to 0. So this gives me the solution as x is equal to n pi as sine n pi is equal to 0, n is equal to 0, 1, 2, so on. So therefore, if the equations are are simple to solve, we go for analytical methods. Go for analytical methods. If we get complex equations, if we have to solve complex equations, complex equations in the sense it is not complex number, it is difficult equations, then we go for some indirect methods, indirect methods called as numerical methods. All these methods are formulated by using some properties of the function. So here, if I say, first let me consider what is an algebraic equation and what is uh, transcendental equation. Let us consider equation of the type of the type f of x is equal to 0. I call this as expression A, right? If fx is a polynomial of degree n in x, or ratio of some polynomial, then such equations are called as algebraic equations. Algebraic equations. If f of x is not a polynomial, say f of x contains some exponential terms or logarithmic terms, expressions, or trigonometric expressions, say, or combination of these, then we get transcendental equations. Transcendental equations. And we make use of certain intermediate valued theorems. In arriving at numerical methods. First one, if f of x is continuous function in AB such that f of A and f of B are of opposite signs, that is, if f of A is positive, then f of B is negative, or vice versa. In other words, if f of A times f of B is less than 0, that is negative, then definitely there exists at least one root or odd number of roots in the interval AB. Right. This is intermediate valued theorem. See, for example, I consider the function. This is x-axis, this is y-axis. This point is A, this point is B. Right. So this is my interval. See, there is a point A. So this is f of A. So this point lies above the x-axis. I assume f of A to be positive. Then there is a point at B. F of B lies below x-axis. So this is the point B f of B. And this is the point A f of A. Right, B f of B and A f of B. Now I have to join these 2 points, and I know f of x is continuous function in the interval AB. So what it means, I can join these 2 curves, these 2 points by a smooth curve like this. So this, if I join, see, this is a smooth curve like this. So this is my f of x. Then certainly at the point of intersection, if this point is the point of intersection, if I call this as, say, C, right, this point as C, then, right, let C be the point at which curve cuts x-axis. Right. What I did, f of A is positive, I assume f of B is negative. That means, right, now I have to join these 2 points. Certainly, since the function is continuous, see, I cannot lift my pen at all in joining these 2 points. Therefore, it must cut, this curve must cut x-axis at least once. See, I can give you a dotted line which cuts the x-axis at odd number of points. See, if I consider this, see here, this is 1 point, this is 2nd point, this is 3rd point. For this fx, there are 3 points. So always, once I join A f of A and B f of B, B f of B, then certainly the curve at least cuts x-axis at least at 1 point or at odd number of points. That's what the intermediate value theorem says. So from this, what we can infer, certainly if if f of A is positive, f of B is negative, or if f of A and f of B are of opposite signs, certainly there is a root. There must be a root, right? Either one root or odd number of roots, but that interval contains the root. That's what the intermediate value theorem says. So these theorems, they give us the idea where the roots might exist. So given a function f of x is equal to 0, I consider the function f of x. I find out the value a and b such that f of a into f of b is less than 0, that is negative. They are of opposite signs. Then I can, by using this intermediate value theorem, certainly I can say there must be a root or odd number of roots. So in that interval, there is a root, right? I can say that is the existence of root in that interval is guaranteed. That's what the intermediate value theorem says, right? At C. Then what is f of x at C is equal to 0. Why? Because it cuts x-axis. So on x-axis, y value is 0. I considered y is equal to f of x as a function. So at C, f of x is equal to 0. Then f of x at C is equal to 0. That is the value of x at the point C is a root. So this is my first intermediate valued theorem, right? So like this, so many theorems are there. This theorem we use at the frequently we use So in almost all the examples, we use this intermediate valued theorems. So with this idea, I am going to start the topic false position method or regular falsy method. So false position method. First, I am going to study false position method, or it is also called as regular falsy method. Right. So in regular falsy method, what we do is we consider, see, let f of x is equal to 0 be the given equation, and let a and b be 2 points or numbers with a with a less than b, such that f of a and f of b are of opposite signs. Opposite signs. Right. Then, if I draw the figure, I assume f of a to be positive, f of b to be negative. So I draw the graph of the curve y is equal to f of x. So this point is a, right? Then this point is say b, and this is the point a, b f of b. This is a, this is b. Now I'll join these 2 points by a smooth curve like this. So this is my f of x. Y is equal to f of x. So this is x-axis. This is y-axis. Now this point I call as a. So this is nothing but a f of a. Then this point I call as b. The coordinates are b f of b. Right. Now I do not know the value of the function. See here, I do not know the curve. I do not know the graph of the curve. So now what I will do is I join the line AB. This is the line AB. This is also called as chord or secant. This is also called as secant or chord. Right. Now, what I will do is, say, now I assume the point at which the chord cuts x-axis as my initial approximation. I call this as x naught. Right. So this is at x naught. What is the value? I assume this as a root. That means what? It should be 0. The chord at which it cuts x-axis should be 0. Then what I will do? I find out f of x naught. This is my f of x naught. Right. Then I check for the interval in which the root lies. See, I check the sign of f of x naught and f of b. In this case, f of x naught is negative, f of b is negative. Therefore, in this interval, there is no root. If I consider f of a is positive, f of x naught is negative. So certainly there is a root in this interval a to x naught. Therefore, what I will do, I consider this chord in my as my next improved root. So this becomes my second approximation. I call that as x1. Certainly, see, then I find out x1. This is f of x1. Right. Then I check in which interval the root lies. In x1 to x0, certainly it is not there, because f of x1 also is of the same sign. F of x0 is also same sign. Then I join the chord a f of x1. So this will be my next improved route x2. So like this, see, since this is the exact route, I am coming towards the exact route in this way. What I do, I assume that the point at which the chord cuts x-axis is my next improved route. So I know how to find out the line joining a f of a, b f of b. Therefore, easily I can find out the equation of this line. So once I know the line, I can easily find out the point at which the chord cuts x-axis. So I have to put y is equal to 0. That's all. So this is the false position method or regular falsy method, right? So now we shall derive the equation now. Now let a is equivalent to a f of a, b is equivalent to b f of b. See, the proof is not there, but anyway, you should know how we arrived at that formula. A f of a, b f of b. The equation of the line joining a f of a, b f of b is given by y minus y1, that is, this is my x1 y1, this is my x2 y2. So y minus y1 over y2 minus y1 is equal to x minus x1 over x2 minus x1. So is given by y minus y1 is f of a divided by y2 minus y1, fb minus f of a is equal to x minus x1, x1 is a, divided by x2 minus x1, b minus a. So this is equation of the chord, right? This is equation of chord, equation of line AB or chord AB or secant AB. Now, what we do, we assume that the point at which AB cuts x-axis is new improved root of root x0. That is, we put y is equal to 0 and x is equal to x0 in the above equation. Right. So if I put that, so I get 0 minus f of a over fb minus f of a is equal to x0 minus a over b minus a. Or if I simplify, if I cross multiply and simplify, I get x0 as what? x0 is equal to a minus b minus a divided by fb minus f of a times f of a. So this is my formula which gives me the improved root. I call this as expression B. So equation B, so this one, 0 minus f of a over fb minus f of a is equal to x0 minus a over b minus a. So this is the equation after putting x is equal to x0 and y is equal to 0, because the x0 at x0, the value, the chord cuts x-axis, so y becomes 0 there. So I find out x0 from this expression and I get this after simplification, x0 is equal to. So this is my first equation, that is, this is my equation which gives x0. Now what is the next step? What I will do is, I find f of x0. I find f of x naught. Fine. Then compute f of x naught. Right. If f of x naught and f of b are of same sign, then the root does not lie in x naught to b. Right. That is, it lies in a to x naught. What we do? Put x naught is equal to b, then f of x naught will be equal to f of b. Use the equation b again to find next improved root. Improved root x1. Right. If f of x naught and f of b are of opposite signs, then there will be a root in x naught to b. Then put x naught is equal to a, f of x naught is equal to f of a, and use equation b again to find x1. Right. We repeat this procedure till we get the root of required degree of accuracy. Right. So now I'll solve the example. I consider the example now. I consider this is again taken from the question bank. It is question number 10. What it says is using false position method, find the root. This is the question number 10 of the question bank. Find the root correct up to, in the question bank they have given 4 decimal places, but I consider 2 decimal places here because this is very lengthy. If I go for 4 decimals, maybe I require 1 hour here to calculate the exact root, which is correct up to 4 decimal places. So instead of that, I consider the root correct up to 2 decimal places of the equation. X log x to the base 10. log x to the base 10 minus 1.2 is equal to 0. Here he has given the roots also. The root lies between 2 and 3. 2 and 3. So now, since I have the root, so now the solution. Now, A is 2, B is 3 already given. Then f of x is what? It is x log x to the base 10 minus 1.2. So therefore, what is f of a? So f of a is, so you can easily find out. So f of a is what? F of a is minus 0.59794 minus 0.59794. F of b is 0.23136. 0.23136. Therefore, f of a is negative, f of b is positive. Therefore, definitely there is a root. Then what is my next root? X naught. X naught is what? It is a minus, that is I have to make use of this root. That is I have to use this one. X naught is what? It is a minus b minus a divided by fb minus f of a times f of a. So this is equal to 2 minus 3 minus 2 divided by fb 0.23136 minus of minus 0. Minus of minus 0. F of a. F of a is 59794. 59794 times f of a minus of 0.59794. Right. So this will be equal to, to calculate, this will be equal to 2.7212. 2.7212. So I got I got x naught. So now what is my next step? I should find out f of x naught. So f of x naught will be minus 0.01693 minus 0.01693. Right. Again, it is negative, less than 0. Now I have to check where it is positive, where it is negative. Definitely, see, f of x naught is negative, f of a is negative. Therefore, the root lies in x naught to b. Correct? No. Root lies in x naught to b. Now, I go for definitely it lies in x naught to b. Now I calculate the right. So now I calculate what I should do. What should be my next step? I should, since I know root lies in x naught to b, what I will do is I'll just change a to x naught. Right. So now put x naught is equal to a, because I'm sure that the root lies in x naught to b. F of x naught is negative. F of a also is negative here. See, f of a also is negative here. Therefore, certainly there is no root from a to x naught. Therefore, I shift this a to x naught. So I put x naught to a. So my a, therefore, a will be equal to what? 2.7212. And what will be f of a? F of a is 0 minus 0.01693. Right. So now I know f of b. What is f of b? F of b is given here, 0.23136, and b is what? B is 3. Right. Now I make use of the same formula again. Therefore, what will be my x1? So x1 will be equal to a minus b minus a over fb minus f of a into f of a. So this is equal to a is what now? 2.7212 minus b minus a, b is 3, minus 2.7212 divided by fb minus fa. Fb is 0.23136 minus of minus 0.01693 into minus 0.01693. So if I simplify this, I get the answer as, if I simplify this, I get the answer as 2.74021. 2.74021. And what is f of x1? F of x1 will be equal to, f of x1 will be equal to 0.3038 minus 0.3038. So it is negative, that is less than 0. Therefore, now see, f of a is negative for me here, and f of x1 also is negative for me. Therefore, since f of a is negative and f of x1 is negative, the root lies in x1 to b. Right. Now, what is the next step? Put x1 is equal to a. Therefore, a is equal to what? 2.74021. What is f of a now? F of x1 becomes f of a. F of a is equal to minus 0.3038. What is f of b? F of b is the same, 0.23136, and b is what? 3. So now again, what will be x2? So x2 is equal to a minus b minus a divided by fb minus fa times f of a. So that is equal to 2.74021 minus 3 minus 2.74021 divided by 0.23136 minus 0.3038 times minus 0.3038. Right. So if I simplify this, x2 will be equal to, I'll just calculate, f2 will be equal to 2.74064. 2.74064. Now, see, I compare x1 and x2, comparing x1 and x2, right? We find that my bad. The roots are same up to 2 decimals. Therefore, that is 2.7 x2 x1 is 2.74021, x2 is 2.74064. So comparing, therefore, x2 will be equal to what? The root. x2 is equal to 2.74064 is the root correct up to correct up to 2 decimals. Thus, we solve the false position. We solve the equations using false position method like this. So I complete